Hi folks, welcome back to another physics lab. Today's lab is going to be momentum, specifically conservation of momentum in the context of collisions. We're going to be colliding one lab cart into another. Now, this lab is a little different from the others. I will actually be performing the entire lab. You will follow along and take the data as necessary, and then you will be left to perform all the calculations on your own. As usual, if you have any questions, please reach out to your professor and get those answered. Make sure to clarify anything that is uncertain before you submit your lab report. So let's get started. Before we actually perform any collisions, we need to find out what the masses of the objects involved are. So let's start by taking the mass of car number one. I'll place it on our digital scale. The mass of car number one is 469.6 grams. You will actually need to convert that to kilograms. That would be 0.4696 kilograms. 0.4696 kilograms would be the mass of car number one. We'll also need to know the mass of car number two. So let's put that on the scale. The mass of car number two is 492.3 grams. Again, we'll need that in kilograms, so you should record that as 0.4923 kilograms. 0.4923 kilograms is the mass of car number two. As we carry out this experiment, we're going to be adding more and more mass to car number one. That will give us the total mass one that is in your data table. We have two bars here. They're both about half a kilogram, but let's check their exact mass. Bar number one has a mass of 493.2 grams. Again, we want this in kilograms, so 0.4932 kilograms. 0.4932 kilograms is the mass of bar number one. Lastly, let's record the mass of bar number two. Place that on our scale, and we can record the mass of bar number two as 497.6 grams. Again, converting to kilograms, that would be 0.4976 kilograms. 0.4976 kilograms. We now have all of our masses measured, and so we can begin getting data for the collisions themselves. Now, we will do 6 trials. The first 2 trials will be simply car number 1 and car number 2. Mass 1 will always be car 1 plus its cargo. It is empty for these first 2 trials, so mass 1 is the mass of car number 1. Mass 2 will always be the mass of car number 2. We won't be loading any extra mass into car number 2. For trials 3 and 4, we'll add 1 bar to car number 1, and for trials 5 and 6, we'll add 2 bars to car number 1. I'll remind you guys of that once we get there. But we're now ready to take data. I'm going to give car number 1 a gentle push, and it will collide into car number 2, which is initially stationary. That is, car number 1 is the only moving thing. V1 initial is the only actual value. V2 initial will be 0. Car 2 is not moving, meaning it has no initial momentum. Thus, all of the initial momentum resides in car number 1. This is an inelastic collision, meaning they will stick together. Once they collide, they become stuck, which means our final mass is the combined mass, M1 plus M2, and they are moving together. They share a single final velocity. What we will read off of our computer is the initial velocity, that is V1 initial, car 1's initial velocity, and then the final velocity, the shared velocity as they move together. So let's go ahead and get our first set of data, and then we'll take a closer look. So let's make sure that car number 2 is stationary. I'll begin to collect data, and I will give car 1 a gentle push. All right, now let's take a closer look at that data. So here is our data set. We can see the velocity is initially 0. I then give it a push, the velocity increases. We're looking at a velocity versus time graph. This is velocity on the y-axis. Once I give it a push, it maintains a constant velocity. We see a flat area of the graph that is the constant velocity of car 1. There is then a collision. That velocity decreases, but after the collision, we again see a constant velocity. It's nice and flat. We can highlight sections before and after the collision and get statistics. I'll increase the font to make this a little easier to read, but I'll also read it off for you. So there is the data for the initial velocity. We can also highlight a section and get the statistics for the final velocity. So looking at this data for our initial velocity, we're going to read off the mean value, that is the average value during the section that I have selected. The average initial velocity was 0.3868, and the units of this graph are meters per second. V1 initial for this trial should be 0.3868 meters per second. After the collision, we should get a lower velocity. And here we can see that our mean velocity during the second section of data I selected is 0.1907. 0.1907 meters per second is the final velocity. Now I won't zoom in on these every time. I'll simply read these off for our next 5 trials, but that is how we take data for this. So make sure to record the initial and final velocities. All right, so we got one set of data. Now we need to do that again. Then we'll add some mass, take 2 more trials, add a little more mass, and do 2 final trials. But let's do again mass 1 and mass 2 as simply cart 1 and cart 2. No additional mass on car number 1. So here we go. Let's collect some data. So for our second trial, we have an initial velocity of 0.4587 meters per second. 0.4587 meters per second. The final velocity for our second trial is 0.2256 meters per second. Again, the final velocity for trial 2, 0.2256 meters per second. We're now ready to add some mass to cart number 1. So for trials 3 and 4, we will add bar number 1 to cart number 1. Mass 1 is now cart 1 plus bar 1. Mass 2 is still simply cart 2. Let's go ahead and collect some data for our third trial. For our third trial, we have an initial velocity of 0.3753 meters per second. Again, the initial velocity for the third trial is 0.3753 meters per second. The final velocity is 0.2386 meters per second. For trial 3, the final velocity is 0.2386 meters per second. Now we can go ahead and take data for trial number 4. For trial 4, again, we'll leave 1 bar on cart number 1. So the mass M1 is the mass of car 1 plus the mass of bar 1. Let's go ahead and get some data. For trial number 4, our initial velocity will be 0.4878 meters per second. 0.4878 meters per second. And the final velocity for trial number 4, 0.3278 meters per second. 0.3278 meters per second. We've now done 2 trials with 1 additional bar on car 1. We're ready to enter our final 2 trials. We are now adding bar number 1 and bar number 2 to cart 1. So mass 1 is now cart 1's mass plus bar 1's mass plus bar number 2's mass. Cart number 2 is still the only thing contributing to mass number 2. Let's collect some data. For trial number 5, we have an initial velocity of 0.3805 meters per second. That is 0.3805 meters per second. The final velocity is 0.2825 meters per second. For trial number 5, the final velocity is 0.2825 meters per second. We've got 1 trial left. Let's go ahead and finish this off. Again, the 6th trial is the same as the 5th trial. Mass 1 is cart 1 plus bar 1 plus bar 2. And mass 2 is still simply cart 2. Let's get our last set of data. For our last set of data, that is trial number 6, the initial velocity was 0.4276 meters per second. Again, the initial velocity for trial 6 is 0.4276 meters per second. The final velocity is 0.3190 meters per second. For trial number 6, the final velocity is 0.3190 meters per second. The rest of this lab is up to you. You need to perform the calculations for initial momentum, for final momentum, initial kinetic energy, final kinetic energy, and you'll be considering the percent difference the percent difference in the momentums, and the percent of kinetic energy lost during the collision. Make sure that when you compute your final momentums and final kinetic energies, you consider the fact that the masses have been combined. The final momentum, the mass is m1 plus m2, and the same goes for that final kinetic energy. That's all for this experiment. As usual, ask for help if you need it. Otherwise, I'll see you all next time.